Your next 5 Caillou challenge is called Weight for Weight. My friend John and I are members of the Fat to Fit Club. John is worried because each month a list with the weights of members is published, and each month he is the last on the list, which means he is the heaviest. I am the one who establishes the list, so I told him, don't worry, I will modify the order of the list. It was decided to attribute a weight to numbers. The weight of a number will be, from now on, the sum of its digits. For example, 99 will have the weight 18 because 9 plus 9 is 18. 100 will have weight 1 because 1 plus 0 is 1. So in the list, 100 comes before 99 because 1 is less than 18. Given a string with the weights of FFC members in normal order, can you give this string ordered by weights of these numbers? And so I don't like that they use the word weight to describe the sort of encoded value when the original value is a weight. To me, that's kind of ambiguous and confusing, but I'll try to make this clear for you. So here's an example, just a bunch of random weights, right? 56, 65, 74, 199, they're not in order, right? And then when you order the number by the weights, they become this. So what you'll see here is that it's the same values as above, but now they're ordered by the sum of their digits, right? So this one was only 1. This one is 9, 1 plus 8 plus 0. This one is also 9, 90. 5 plus 6 is 11. So you can see how these are increasing, right, in value as you go up, which is what we need to do. When two numbers have the same weight, so like this example here, right, both of these were 9, let us class them as if they were strings, alphabetical ordering, and not numbers. 180 is before 90, since having the same weight, it comes before as a string, right? Because when you do these alphabetically, the number 1 comes before the 9, and so 180 appears first. All numbers in the list are positive numbers, and the list can be empty. That's an important one. So I think I've given you enough there. So go ahead and get started. I will add one more note that you're returning their actual weights and not the encoded values. So you're not returning 1, 9, 9, 11, 11, 11, 14. You know what I mean? So you're going to be using the actual values, but they'll be ordered based on this kind of secret code assigned to a person's weight. I don't like saying weight because this is the weight, but I think that's clear enough. So I'm gonna clean mine up a little bit here. You go ahead and knock this out and come on back when you're ready. I'm going to use LINQ for my solution. I think it works really nicely here. It's not forced. And they've got some very helpful methods for doing this sort of thing. So first things first, let's take care of that edge case, right? They warned us that the list can be empty. And note that they're not actually giving us a proper list like we think of in C#. It's this string separated by spaces, right? And I think this parameter name is terrible, so I'm going to call mine weight list. Okay, so we could say if you've seen string has a method is null or empty to check for either of those conditions. In those cases, let's just return the empty string. I don't think they told us what to do, but this will work. And if not, we'll fix it. So, good. All right, now to the general case, how we're going to deal with this. So we're going to need something where we convert these values into their code and then sort on that. And then we have this additional clause where if the coded values are the same, then we sort of fall back to string ordering, natural string ordering. And the string class already has this built in. You know, it can do compares between characters, and you know, you can imagine if you sorted an array of strings, it can do that because somebody already defined what it means to compare characters for that class. So we could take advantage of that. We don't have to implement any of that like we've had to do in the past with custom classes that needed unique comparisons that weren't built in. So let's do that. Let's start by splitting the string. I'm going to take it and make a string array out of it. And we've done this enough. We could say string weights. I'm sorry, that should be a string array, right? And we could say weight list split. And remember, you just give it the character that you want to split by. And if you look at this example input, it's just single spaces, right? And if you wanted to do some additional validation to make sure these were all separated by a single space, they were all numeric characters and not letters or punctuation, you can go ahead and do that. The tests, though, aren't going to mess with you there. So good, at this point, instead of one string, now we have the string 56, the string 65, the string 74, etc., all contained in this array. So that's a good start. Now I could start using my LINQ methods to sort of process that. And I'm going to make a separate variable for this. You can combine it at the end if you want. But I'm going to say, I'll just call it ordered, it doesn't really matter. But we'll say the weights collection. And we know that LINQ has this order by. Not sure how much we've used this, maybe we haven't. But order by, there you have it, sorts the elements of a sequence in ascending order. And that's what we want, right? Ascending order. There's another method called descending if you happen to need, if you have a descending use case. But we saw we're starting with low values and going up, so we're ascending. This is good for us. Sorts the elements of a sequence in ascending order according to a key. That should work for us. Let me see if we have a good example here. So you notice they use it to order these three pets by their age. And you notice that it goes out 1, 4, 8. Cool. So that's what we want too. And note that you're not actually changing the pet in this case. You're just saying to order them by their age. So we're not transforming the input. We're not going to modify it into some other form. We're just going to say, you know, we want to preserve the original weights, remember, but we just want to order them on this one criteria. We'll have a follow-up too for when there's ties. But let's do that. We could say weights, okay, good, order by. Now, how do we order them? Well, we're going to sum up the digits in the weight. So for my, let's put that lambda in here to take care of that. I'm going to call my parameter weight. I think that's very appropriate for a collection called weights. So remember, weight is going to be any one of these individual strings, so 56 to start. And what do we do with that weight? Well, we can basically go through each of the characters and convert them to an integer value and then add them up. So you could do something like weight, and I'm going to use another LINQ method called select. And remember now, weight is a string, so when I do select, it's going to run this transformation on each character in this weight parameter. Okay, so for that, I usually use ch for my character variable names. You could call it digit maybe, or something like that. It doesn't really matter, whatever you think people would understand the best. And what you could do for numeric values is you can take it and take your value, which should be 0 through 9, right? They promised us, and they're right. They won't mess with you there. It's going to either be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's what char is going to be here, right? And you subtract it from the character 0. Now 0 would have some ASCII representation. Let's say it's 112. I'm sure it's not, but you know, whatever. You can imagine character 1 is just going to be 1 ahead of that, so like 113. When you subtract those, it would be a difference of 1, and you get that one value in integer form that you actually want. Those aren't the right ASCII values. I just made those up, so don't quote me on that. Okay, so now at this point, this thing is returning a collection of integers. And do you remember how, so with the first example, it'd be 5 and 6, right? There's just 2. So we'd have 2 separate integers, 5 and 6. And do you remember how to add those up with LINQ? You can say sum. And so that will add the 2 values and give you an 11. Good. So this gets us halfway there, but we still have this issue with the ties with 180 and 90, right? I suppose we could run it like this just to illustrate. So we've got this collection then, and if we stopped here and we need this part anyway, do you remember how we've used string join method to sort of, when we have one of these IEnumerable collections and we need to just kind of put it into a string form, we say separate the values by a space. In some contexts, you might want to separate them by a comma, but here we can clearly see the output is a space, and then you can put ordered in here. Now this is going to come up short. It's not going to do the tiebreaker, but I just wanted to illustrate that. So string lengths are both, expected. 11, 11, 2000, 10,003, but was, look at this. You can see we're mostly there, right? A lot of our values are right, but it messed up on these first few. And you'll notice for all 3 of those inputs, the value adds up to 2, right? 2 plus 0 plus 0, 1 plus 1, 1 plus 1. But we need that tiebreaker thing because 11 alphabetically should appear before 2000, right? 1 is less than 2. That's how we'd sort those if they were words. So we need to fix those 3 to get there. Well, LINQ to the rescue again because they have this handy then by. And notice the then by descending as well, but we're still working with ascending. Look at this, performs a subsequent ordering of the elements in a sequence in ascending order. That's pretty cool, right? So it's giving us like a second stage kind of, right? We got it mostly right with our first one, but we need this kind of tiebreaker thing, a second pass, second filter kind of thing. And then, yeah, if you want, you can read this and go down. They might have some examples here. Fruits. So order by their length and then by fruit, which is string, so alphabetical for the same length. So apple and grape are the same length, but A comes before G, so apple gets listed first. That sort of thing. That's exactly what we want, right? And notice how because fruit was a string, for their lambda, it's really easy. You just use the parameter itself. You use the string itself. You get to leverage that built-in functionality I already told you about, where strings know how to compare against other strings. So that should make our lives pretty easy. You can do, oops, then by. So where did our parenthesis end? So order by gave us those values like we have down here, right? And now we need to order them, do that tiebreaker kind of thing. So we'll simply say, we'll just use wait to wait. If I test now, that should be cleaned up. And there it is. We'll go ahead and hit the larger collection here. And still green. So we are clear for takeoff. So yeah, one thing I would do when these things get a little, they're running a little long, I like to just kind of move it to another line so you can read everything. I'll leave it up to you if you think that's ugly to do it this way. I don't like to have to scroll on a screen, so I'll do it like that. And of course, if you really wanted, you could combine all of this. Instead of making weights, you could just substitute this whole bit in for weights, and instead of making ordered, you could just substitute the whole thing in there. If you want to really cram it down, on one long line, knock yourself out. But I think I'll submit mine like this. This is good enough for me. But yeah, hopefully that was a good introduction to order by and then by. And I imagine you could just keep chaining these then bys if you had other sort of tiebreaker conditions you had to deal with. So yeah, I think LINQ works nicely here. Sometimes I use it to demonstrate it, but it feels kind of forced. But I thought I appreciated it here. I thought it was nice for doing the solution. So probably, yeah, I'll go ahead and submit like this. See what you can gather from other people. There you go. See how they broke it up on other lines too, instead of putting one long line. Same kind of thing. Pretty similar. So there's 48, right? Maybe that's what 0 is in ASCII, 48, probably. Cool, but yeah, you don't have to watch me looking around here. Go ahead and see what you can find that's useful to you in there. Otherwise, yeah, let me know what you came up with. If you have questions, comments. Otherwise, we'll keep rolling. Thanks for watching.